Okay, welcome to your next lesson on rates. So, a couple of things I want to talk about first. The first is here called cross multiplication. The last day we talked about things called multipliers. This is another strategy to figure out how to make equivalent fractions that might come in handy here. So the question here is, when do you use cross multiplication? Well, the answer would be when you have two equivalent fractions. So you can see the example below, right? 3 over 8 equals x over 24. So you could look like for a multiplier, like what we did in class. So 8 times something is 24, right? So in that case, it's 8 times 3. So the multiplier to the bottom would be 3, and to the top is also 3, right? So 3 times 3 is 9, x equals 9. Another way to solve a question like this is through cross multiplication. So, same question. Let's do this. 3 over 8 equals x over 24. And we're going to cross multiply, which means we're going to multiply the 8 times the x, which gives us 8x. Then I'm going to multiply the 7 times the 3, right, which is 72. And now, look at that. It's a one-step algebra equation. Divide by 8, x equals 9. Okay? So keep that in the back of your head as we move on. But let's talk specifically about what a rate is. Now here it says a rate is a comparison of two quantities measured in different units. Right, now when we talked about, remember, ratios, they were the same units, right? We talked about students or balls or whatever it is, or cars, right? The ratio of blue cars to black cars. Those are the same units. You know what's a rate? If it's different. So this example, right, is talking about money and weight, right? $1.79 per 100 grams, right? So that's an example of a rate. Now, if I wanted to figure out, let's say, how much it would be for 200 grams, right? I would deal with a multiplier or perhaps an equivalent fraction. So I know that, let's do 100 grams is $1.79. Right? An equivalent fraction would be 200 grams. Right? I'm going to multiply by 2. That's my multiplier. So on the top here would be 179 times 2. Whatever you do to the bottom, you got to do the top, which would be, oops, that is definitely not right. Let's try again. 179 times 2. There it is. 358, right? So you've doubled it. Okay? So why don't you look at this one here, right? At 72 beats per minute, let's figure it out what it is for 5 minutes. How many beats would that be? Okay, so you can pause the video and check your answer next day. Okay, welcome back. Now let's talk about what we can do to how we express rates. We talked about ratio notation last day, all that stuff. Now, a rate can be expressed as a fraction. You've probably seen it lots of times, but never really thought of it as a rate. Like, for example, 100 kilometers per hour, right? Speed is a rate, and it's a fraction. What that's saying is 100 kilometers in 1 hour. Right? Now, a rate, unfortunately, cannot be expressed as a percent. Right? So no to the percent, right? Because a percent is a ratio that compares quantities expressed in the same units. Right? So if you're talking about a percent on a test, right, it's 8 marks out of 10 marks, right, out of a greater whole. You can't do that when you have rates. So fraction is only. Now, something that's really common is this thing called a conversion rate or a unit rate. So a unit rate is how much or how many for one quantity. So let's go back to this this speed up idea up here again. So let's say I can do 35 kilometers in 8 hours. Wait, no, that's not realistic. 35 kilometers in 6 hours. And I want to figure out how much I can do in 1 hour. Right? So I know that 35 kilometers in 6 hours, I can set up, right, 6 to 1, right? I have to divide by 6, right? 6 divided by 6 is 1. Do it to the bottom, you do it to the top. 35 divided by 6, right, looks like 5.8 kilometers. So the unit rate here, and then we got repeating 8, so 5.83 kilometers per hour. Now you might just be okay skipping this step, right? Maybe you just said, okay, I'm just going to go 35 divided by 6, right? And that'll give me kilometers in 1 hour. Go for it. Sounds great. So why don't you try these 2 questions over here and pause and check back at the answer key next day. Okay, so we have a word problem here. It's a little bit more involved than those 2 up here. This one says, Mr. Henning uses 51.4 liters of gas to travel 658 kilometers. What was his rate of fuel consumption? So, what we're looking for here, if we're looking for a rate of fuel consumption, we're looking for a unit rate. If you're not quite sure what to do, it's usually that you're trying to figure out how much it is for one, right? Because if we're all traveling different distances and using different amounts of gas, it's hard to compare, right? So to make it in a language you compare, let's just all talk about how much it is for 1 kilometer. Then we can see which car is faster, all that sort of stuff. So we need to put it in 1 kilometer rather than 658 kilometers. So let's use the shorter cut here. I'm going to go 51.4 liters. Divide that by 658. Right, so my units, liters over kilometers. So that's where that liter kilometer comes from. And in my calculator, I'll just go 51.4 divided by 658, and it looks like 0.078 liters per kilometer. Right? So you'd have to look at other cars to see if that's a good rate or not, but you should have a concluding statement that says his fuel consumption is 0.078 liters per kilometer, right? The unit rate, that's how much it is for 1. All right, let's turn the page over, and we've got another example here. So it says, a ruby-throated hummingbird and a monarch butterfly travel similar paths across the Gulf of Mexico. The distance is just over 800 kilometers. It takes the hummingbird 18.5 hours, the monarch 41.6 to cross the Gulf. Calculate each speed to the nearest hundredth. So here we go. We want to see which one's faster. They do the same distance different times. We need to make it a unit rate. We need to make it per kilometer, or per time, so that we can actually kind of compare. Now remember that nearest hundredth means 2 decimals. So we've got 2 questions in one. Let's do the hummingbird first. All right, so here's the hummingbird. I know that the hummingbird can do 880 kilometers in 18.5 hours. Remember, this is another way to divide that line between. So 880 divided by 18.5. I'm not very good with the calculator today. Let's try again. 880 divided by 18.5. There it is. Sorry. Equals, we've got 47 to the nearest hundredth, so 2 decimals, 57 kilometers per hour. That's pretty fast, right? That's how fast you drive in the city, right? About 50 kilometers per hour. So let's do the butterfly and see how fast this butterfly goes. So butterfly, it's a long way for a little butterfly to go. Even a hummingbird, eh? So we have the same distance, that 880 kilometers, but this one takes 41.6 hours. So all these units are really important, right? You need to, I know it slows you down, but take a couple minutes, seconds rather, write those units. It'll help prevent errors later. This guy goes 21.15 kilometers per hour, right? He's slower. So that's all you need to do, right? Concluding statement. The bird travels at a rate of 47.57 kilometers per hour. The butterfly is 21.15 kilometers per hour. Almost half the speed. Okay, so why don't you try a couple practices here determining each rate, or rather I probably should say unit rate. So how much is it for 1 second, 1 hour, or 1 can? Okay, now with unit rate, the next logical thing to do is talk about unit price. That's kind of what C was over here. Right? You were trying to figure out how much it was for 1 can, right? We're talking money now. So unit price is similar to unit rate, that it makes it easier to compare costs of similar items. Right? So if I had, example here, $9 for 5 cans, but a different variety was $7.50 for 4 cans, right? It might not be as intuitive to see which one is cheaper. And this is kind of something it's nice to know about when you're shopping. So let's try this question down here with Brett. So Brett goes to the grocery store to buy his favorite brand of orange juice. He found the following container sizes and prices, right? So a variety of sizes. Let's figure out which container is the best buy. And I often think people think the largest one is, right? It's that whole Costco idea, buy in bulk. But you can't just assume that here. We got to prove it. Who knows what these supermarkets are doing, right? So let's make sure we're getting the best deal possible. So I want to figure out how much it is for 1 milliliter. Or maybe you could do it the other way around. Maybe you want to see how many milliliters it is for 1 cent. It's okay, but typically you do the money per volume. Totally up to you though. So let's do the first one. $0.59, so 59 cents for 250 milliliters. Right, let's see what that is. 0.59 divided by 250. So these are tiny numbers, 0.00236. Right, so less than a penny per mil. Seems like a good deal to me. $1.09 for 500 milliliters. So 1.09 divided by 500. 0.0218. So it's cheaper, right? It's a smaller number. It's hard to see when it looks like this, but smaller number. So in this case, as we're getting bigger, it's getting smaller. Let's try that very last one. $1.99 for 1 liter. Now, it's got to be the same unit, so I got to talk all milliliters if I want to actually make an accurate comparison. So remember that 1 liter is 1,000 milliliters. Right? There we go. So $1.99, and this is obviously not really worrying about tax or anything, ends up being 0.00199 per milliliter. So your cheapest one is the biggest one in this case. So the best buy is the 1 liter for $1.99. Okay, so last question here for you to do, very similar to the ones that you did before. This time you're comparing the price of nuts, different volumes, different prices. How much is it for per 100 grams? Okay, so not per 1 gram, but per 100 grams, right? So maybe you want to do cross multiplication, maybe you want to set up a ratio. So this is not a unit price, right? So see what you can do, and again, check the key. All right, we'll see you in class.